maps and stuff. And it can be put on a car, or it can be put on a boat, and that's kind of a bit of an example of what those images would look like, those maps. So the reason why it's a little better than, say, maybe taking a photograph is that the advantage is that it's 3D. You can tell X, Y, and Z position of any point on that map. Okay, so that's just to give you an example. So those are the kind of maps we made. And it's pretty cool because, so for example, this one, it was taken by a plane, but you can, just by using a specific software, you can look at it even on a 2D, from a different angle. I hope I'm making sense. So yeah, these are just a little bit more pictures. So that's kind of what it looks like when it's on a plane being scanned. And those are some of the maps. It could also be used to scan, so say the space shuttle, when it re-enters the Earth, it loses tiles. I think you guys have heard a little bit about it before. So you can use these lasers to scan and see where it's missing a tile, something that our naked eye couldn't necessarily see. Okay, so just a little bit, so it seems really complicated, but the basics are very much stuff that you guys might have learned. So who knows the formula to find distance if you were given, say, speed and time, right? Does anybody know? Exactly. So in this case, we know the speed of light, right? So that would be your speed. And in terms of time, we know when we send a pulse of laser, and we know what time we receive it back. By that, we can calculate the distance. And that's how we can tell exactly where on Earth that point might be. So, it seems very complicated, but the foundations are stuff that you guys learn too. They call it LiDAR specifically because it's called light detection and ranging. It's exactly what it stands for. That's to give you a little bit of an idea. And then to add to it, they also add a GPS so that you can tell. So say in this case, the plane would have a GPS, and that GPS would be connected to the system, which would tell you where on Earth this point is. Pretty neat, right? The other project that I worked on that used this laser was actually a space project with NASA. It's called the OSIRIS-REx project. So they're going to be sending a spacecraft, a space satellite. They're going to be sending a satellite to an asteroid called RX 36. A really boring name, but 1999 is when it was discovered. They're going to be sending the spacecraft to this satellite to this asteroid. It will be scanning the surface and then grabbing a sample and bringing it back to Earth. So that's expected. So they're expected to launch in 2016. They want to reach the asteroid in 2019, get the sample, and come back in 2023. The contribution that Canadians are making is the OSIRIS-REx POLA instrument, which is what the company that I was working at was working on. So I'll give you, So that's what the spacecraft looks like. And there's a bunch of different instruments, but the ones that we are contributing, Canada's contributing is POLA. Unfortunately, that's the only one that Canada's contributing. But still, it's still pretty impressive, I think. So that's to give you an idea. So what is the purpose of this specific instrument? It's supposed to, once it's about like a kilometer away from the asteroid, it wants to scan the surface of the asteroid to get an idea of what the asteroid looks like, the topography, and and then it further scans to decide where it wants to land to pick up samples. So that's what the Canadians are working on. So that should give you an idea what it would look like. If you can see, this would be the sample grabber. It would go down and grab the sample, and that's the scanner that would be telling you, okay, this would be a good site to pick up some samples. And that's what the 3D model of yeah, the instrument looks like. It doesn't look very impressive, but the kind of stuff it does is pretty impressive, I think. Yeah, so that's just a little bit about, oh, so what did I do? Did I have anything? Oh yeah, okay. So what did I do in this project specifically? So when I say it's a Canadian contribution, it's through the Canadian Space Agency. The Canadian Space Agency contracted it out to another company called MDA, which then further subcontracted out to us, which was Optic. And what I did was that I was a systems engineer at this company where I would be the main person that communicated between our customers, which was MDA, and our scientists and our other engineers, the mechanical designers, and the science team, because there was a science team at York that was working on this project. So they come up with objectives that they want, and they say, oh, we want to be able to measure down to 7 millimeters. Can this system do it? And I would be the one that would go back to our scientists and our engineers to say, okay, is this possible for us to do? Other things would be, because some of these engineers, they don't necessarily know what it's going to be used for and what kind of environment it's being used. So yeah, once again, I'd be that person to communicate that. So like, for example, in this case, they don't necessarily know, so they know that's being sent to space, but they don't realize that the radiation of the sun is a lot worse when you're at that distance, right? And you don't have the atmosphere to protect it. So yeah, that's kind of, and then I would produce documentations that would be submitted to the CSA, Canadian Space Agency. Yeah, so that's just a little bit about what I did at that company for that project specifically. Yeah, it's pretty neat. Canadian Space Agency is not as big as NASA, but it's still, yeah, anyway. Point is, when you do become a space engineer at some point, or support the Canadian Space Agency, because they don't do enough, I feel. Yeah, anyway, so people always ask me, why did I choose engineering and technology? Was it something that I always knew I wanted to do? Hell no, I didn't. And that's the truth. Yeah, did I know exactly what I wanted to be? Was I like the top of my class? Not at all. I was pretty average. Okay, I'll give myself a little credit. I was like a little bit above average. But yeah, I was just a regular kid who didn't know no, not anymore. I'm too old for that. I call it kid at least. But yeah, I was a regular kid, didn't know what I wanted to do. I just knew that I liked science and math at the time. And I read a book about space, and I thought that was really cool, and that's why I applied to space engineering. Exactly. It was, I figured if I didn't like it, I could always switch out of it and do something else. But when I came to university, that's when I realized, okay, this was something I really liked doing. Yeah, it's something that I really like doing, so I stuck with it. Yeah, and it wasn't all easy breezy, that's for sure. There were courses that were tough, but there were certain courses, even though they were tough, it really inspired me. I thought, oh wow, this is really cool science. Like, I really inspired me, even though it might have been tough. And those are the kind of moments when you realize, oh, this is what I really want to be doing. Yeah, so I stuck with it. Then like I said, I worked for a bit and I really liked it, but I knew that there were certain aspects that I was missing. So, and I wanted to gain more knowledge about those things, which is why I came back to school, which is why I'm here at Seneca now, doing control systems. Because at the end of the day, whether it's a space system or if it's a computer right here, it all, the basics are pretty much the same. It all involves electronics, it all involves control systems and communicating between these different systems. Yeah, so that's a little bit about myself. So when people ask me for advice, I've not made it obviously myself either. I'm not any big shot either. But the things that I find that make girls who have gone into science and technology, even though you've met some of the WIT members here, and we're really different. Neeraj is a lot more quieter. Saida is the fashionable one, obviously. Nishani is super passionate about everything, including tomatoes. But one thing that I think makes us stand out, Chul Chul. Yeah, you've seen how awesome she is and her robotic arm.
Not a big
But the point I'm trying to make is that even though we're really different, one thing that's common, I think, between us is that we've all got this drive, and we're all really dedicated and passionate. I think you presented earlier this morning too, and I think from that itself you can tell how passionate she is about technology. Yeah, it's not going to be easy, but it was definitely worth, what's the word? It's not easy, but just as long as you're dedicated and you've got that persistence, it's definitely doable. It's not tougher than any other degree that you might pursue. That's just my opinion. It takes effort, but that's about it. And also confidence. I think that's something that makes us, and well, there's like two guys here. It's okay. But one thing that I think that affects girls more so than guys is that we tend to question our abilities, especially when it comes to technology. We tend to think, oh, maybe we don't quite get it. We don't. Oh, it's too complicated. These guys know more about computers than I do, or blah blah blah. Don't doubt yourselves. I was really inspired by this. Has anybody heard of? I can't even remember her name. Sheryl Sandberg. She's like the COO of Facebook. She gave a TED Talks, which I really recommend you guys checking out and reading her book called Lean In. She talks about how women they tend to be the ones that they don't want to stand out. They want to blend in. They want to sit back and they just want to fit in. She really talks about how you should sit in front of the class or sit and participate and don't be afraid to stand out. And this is one of the things that had really inspired me. She said, I still face situations that I fear are beyond my capabilities. I still have days when I feel like a fraud. And I still sometimes find myself spoken over, because there will be people that do that. But she says, but now I know how to take a deep breath and keep my hand up. And I've learned to sit at the table. And she's essentially talking about how, you can be at the table with the rest of the guys, that you don't have to be the good person who sits at the back. You can be one with the guys too. The last that I wanted to say as well, being women, I know it's a stereotype, but it's also true. We tend to be a lot more creative than guys, no offense. Guys, we have other things that we might be passionate about, like arts and crafts and, public speaking that we might like or want to develop. So when you're in university, if you do decide to take something related to technology or engineering, I would recommend joining groups like WIT, Women in Technology, or Engineers Without Borders. They're supposed to be here, but they're not. Because those kind of organizations help me really build my confidence, whether it be speaking in public or just pursuing other interests outside of just engineering. So if you do decide on taking engineering, you don't have to be just an engineer. You can be a bunch of things, which I think that a previous video definitely talked about and was pretty. Anyway, that's just my ramble and 2 cents. But yeah.
Hi,
Do you have any questions?
Thank you, that was great. I just wanted to ask you said that you attended university.
Yep.
And then after that you came to Seneca to fill in some gaps. If you could speak a little bit to the females here about differences of your experiences in university versus college, and what college was able to give you that you didn't get in university.
Sure, yeah, definitely. Being in university, I don't know, I can only speak from York's perspective because that's where I was. But your universities are such where you have to kind of, if you ask me would I do it the same way, I don't know, but the truth is that I find that they talk about how colleges are a lot more hands-on, and it's really true. They have, Seneca has a lot of open labs and stuff, which I really appreciated, because when I was in university, I didn't get those opportunities to be a lot more hands-on. And that affected me when I was at work, because I was always really reluctant to get my hands dirty and work with the guys, with the technicians, because I was really, because I wasn't as comfortable, or didn't get that which I think really helps when you're at places like Seneca, because I felt that that was something that was great. Universities kind of, so would I do it differently? I would probably, I think I would have started out with college, and then if I could transfer over to a university, that I would have done that. I don't know if those options are there, and I'm pretty sure there are. Because at the end of the day, sure, there are also limitations to colleges too. Sometimes you might want to expand your learning, which a university can give you. Am I making sense? Or
A lot.
Yeah? A lot? Okay. Yeah, so, yeah, I don't know how to explain it. It was
nice to have both experiences, basically.
yeah, it was nice having both experiences, because universities definitely kind of throw you in the deep end and try, kind of expect you to swim, but you eventually learn to swim. Whereas colleges take the approach where they help you out throughout this couple of steps, and then you're